All right, well done. We are at the last section of chapter 1, so we'll study this one. We'll do a review and then celebrate our knowledge on Friday. So these are some warm-up algebra problems. We combine all like terms. So these are going to give us 6x equals 180. Divide by 6, divide by 6. We get x equal to 30. All right, I would like you to try this next one. Okay, if you did it right, here it comes. 13x minus 1, we combine like terms. We add 1, divide by 13. Hopefully you got x equal to 7. All right, this one is kind of like, I want to kind of practice working with when you read something, how do you interpret that algebraically? All right, so when we run into the word difference, difference means subtraction. A number, so that's the something that we're looking for, so that's how we use the variables. The word is usually describes an equal sign. So we do some stuff, is, and then that we do the other stuff in the other. So the difference between what? A number and 14. So 14 minus x. Could somebody write x minus 14? Probably. You know, it's all in the eyes of the beholder, but we're getting better. Is 8. So that means it is equal to 8. 14 is 7 times the difference between a number and 2. So there's a lot going on. 14, you know, that's obviously the number, is, so it's equals 7 times, so we're going to multiply, but then the difference between a number and 2. So I see this as x minus 2. So I see this as 14 equals 7 times the difference between a number and 2. All right, practice makes perfect. Hey, today we are going to talk about understanding the notation and the vocabulary of pairs of angles. So if I say this is a pair, you need to know what algebraic or what mathematical interpretation. There are 5 today: adjacent, supplementary, complementary, linear, and vertical. They each have, if I say they're adjacent, you should know this: supplementary, complementary, so forth. So that's our goal. All right, let's start it off. Let's isolate a little bit. First of all, adjacent angles, simplest pair out there. They don't really carry too much weight. It's just more of a physical thing. 2 things have to happen. They have to have a common vertex and they have to have a common side. So adjacent is right next to. If you live adjacent to someone, they are your neighbor. So we'd say angle 1 and angle 2 are adjacent. We would say angle 5 and angle 6 are adjacent. So nothing special except for they share a vertex and they share a side. So they're right next to each other. Very good. That's it. All right, complementary angles. So this is now we're getting into some algebra here. They're the 2 angles that when you add their measures together, you get 90 degrees exactly. So they can be separate, like this case, a 20-degree angle and a 70-degree angle certainly add up to 90. So 20 plus 70 equals 90. So they are complementary. Otherwise, we don't know what the measures of 1 and 2 are here, but do you see how this box means 90? So implies 90 degrees. So the 2 of them together make 90. All right, those are complementary angles. Not too tough. Supplementary angles are going to be angles that add up to 180. So complementary 90, supplementary 180. C comes before S in the alphabet. 90 comes before 180. So the order's there. They can also be separate. So 115 and 65. 115 plus 65 equals 180. So that they are supplementary. And notice how they're along a straight line. Straight line. that implies it is also 180. So that right there is 180 degrees. So therefore 3 and 4 are supplementary. All right, straight line. This is the book. If you want to print out the PDF notes, they're certainly here for you. Uh, Basically the same thing as I just did. Let's do some examples. All right, and you're going to get a lot of figures, and you have to do stuff with it. Complementary, they 90 degrees, so that's what I want to think about. Are there any angles that add up to 90? No, no. Oh, looks like 53 plus 37 equals 90. Yes, it does. So we would say angle CAB and angle RST. Those are complementary since they add up to 90 degrees. Supplementary, I'm looking for two angles that add up to 180. These don't, oh, 53 and 127, I think. Yep, 127 plus 53 equals 180. All right, so that means angle CAD, this one, and angle RST. Good. Adjacent angles means that they share the same vertex and they share a side. So obviously, in this picture, we are looking at this and this. So that is angles DAC and angle CAB. DAC and CAB. Awesome. Okay, so how do we use the vocabulary to write an equation and then hopefully solve it? So complement, that means 90 degrees. So when you see complement, think 90 degrees. 1 and 2 are complements of each other. That means angles 1 and 2 add up to 90 degrees. So we'd say measure of angle 1 plus the measure of angle 2 is equal to 90. They tell us that measure of angle 1 is 62. I'm going to subtract 62 from both sides and I get 28 degrees. Boom. So that's all about knowing vocabulary. Let's look at the next one. Hey, angle 3 is a supplement of 4. That means the two add up to 180. So I would say the measure of angle 3 plus the measure of angle 4 is equal to 180. The measure of angle 4 is 47. So measure of angle 3. Hey, we're going to subtract 47 from both sides, and we get 133. 133 and 47 make 180, therefore they're supplementary. All right, so 1 and 2, we're going to use this picture. Boom, let's go with green first. Okay, can we name two adjacent angles? You bet. So I see this and this because they share the side GK. So angle FGK and angle HGK. And they share the same vertex. All right. So we're moving to complementary. Two angles that add up to 90. Hey, I noticed that 41 plus 49 equals 90. So a lot of times you have to look and find these. 41 is going to be angle FGK, and the 49-degree angle is GKKL. So that angle and that angle. Those are complementary. Supplementary. Supplementary, two angles add up to 180. Do we have any? Ooh, the 131 plus 49, I think is, yep, that's 180. So this angle and this angle are going to add up to 180. So we would say that is angle HGK. HGK. And now I name this one GKL. GKL. All right, I think I'm going to keep going with speed as an important factor. So when viewed from the side, so this is a weird picture. And so I redrew it from the side being mathy. It's kind of cool if you think about it. If you've ever done this where you kick that and it comes back, or you throw in a baseball against it, it's kind of cool. All right, they formed supplementary angles with the ground, you bet. So supplementary right there, we're thinking 180 degrees. So this is pretty straightforward. I think. Yep. If you want to label the sides B, C, E, D if you want, because of this, you can. But I think it's pretty evident that we're going to take one angle right here plus another angle and add them equal 180. So do the math, you get x equal to 34. I think it asks for the actual values. So the actual values in this case are going to be plug in the 34 into the x. And so 4 times 34, 136 plus 8, 144. So that's if they want to know the exact value of the angle instead of just solving for x. All right. Perfect example of using the word complementary. They are complementary, so that means 90 degrees. The measure of the angles are this and this. So we are going to add those together and get 90 degrees. Hey, this is why we do all those practice problems, because once you get here, you should feel comfortable with your skills to say, oh, I got this. I'm going to finish this strong. I'm going to pick the right answer and we're going to celebrate it. So 13 minus 1, add 1, divide both sides by 13, and you get x equal to 7. But they might want to know the values of each angle separately. So you're going to substitute x equal to 7 into both of those, plug them in, multiply them out, and you get 26 and 64. Cool little way to check, do those add up to 90? And yes, they do. Check. 64 and 26. All right, two more pairs. A linear pair at vertical angles. So a linear pair is a pair that are adjacent, so they're right next to each other. Adjacent, they're right next to each other, and they add up to 180. Sometimes this is called well, we know this is called a straight angle. So it's so basic, but if we say linear pair, you need to associate that with supplementary immediately, and life's good. So the idea is if you see linear pair, think of this picture and know that 1 and 2 are going to be supplementary. Hey, vertical angles are pretty cool. That's when we have two intersecting lines. We actually get two pairs of vertical angles. Angles 4 and angle 5 is a vertical pair, and angle 3 and angle 6 are a vertical pair. And just think of it as opposites. So those two are equal, and these two are equal. Always. Makes sense, doesn't it? Okay. All right, so we're walking along the woods, we see this, and we're like, hey, I wonder what all the linear pairs. Remember, a pair is only two, so we're looking at two angles that form a straight line that are adjacent. So a linear pair here is, let's go blue, 1 and 4. That's a linear pair. And 4 and 5 are a linear pair. I will tell you that angle 1, angle 2, and angle 3 form a straight line. That's good, but it's not a pair. There's 3 of them, so it's not good. Hey, a vertical pair where two lines intersect. In this case, we are looking at our good friend. The only pair opposite of each other with intersecting lines are 1 and 5. That would be the only vertical pair. All right, two angles form a linear pair. Hey, I know that picture. It's a straight line. Measure of one angle is 5 times the other. So the key is I would draw a picture. And if you draw this because if it's a linear pair, who cares if it's accurate? It says the measure of one angle, let's say this one or this one, is 5 times the other one. Oh man. So if this is x, I call this 5x. Find the measure of each angle. That's weird. Oh, wait. A linear pair always adds up to 180 because they're supplementary. So 5x plus x equals 180. And that should look familiar. We did that as a warm-up problem today. We add those together, divide by 6. So we know this is 30, and 5 times 30 is equal to 150. So those are the two angles. They certainly do add up to 180, so they're supplementary, and one is 5 times the other. Perfect. Yep. All right, there you go. I tried to keep it around under 20, and I got to 16 minutes. So let me know if I went too fast today. Thank you.